Good evening, everyone. I'm Jacqueline. So it's a good honor that today you all participate in this webinar. This webinar is a topic we'll talk about smart design and manufacturing in the Moldex3D. And if we change another word to say about smart design and manufacturing, actually it's also like a topic in here. It's called smart factory. Okay, and so we are going to talk about a smart factory in Industry 4.0 era. Okay, but what is smart factory and what is Moldex3D character and our idea in this one? Before we start, I would like to we would like to review about the history of the industry, and then we'll move on. So at the beginning, let's see, in each generation or each era, like era 1, 2, 3, 4, actually the development of the industry actually all follow one topic. One perspective is we want to save more money, but earn more money. Right, so like industry 1 era, like we have steam power, so we can use more machine, increase the profit. And then industry 2, we use assembly line to increase the efficiency. And the industry 3 era, also at this timing, CAE also came out. The automation technology help us to reduce the manpower, to reduce the pay under manpower. But how about Industry 4? Everyone will use a lot of words to explain about Industry 4.0. But how CAE worked in the Industry 4.0 era? I think a lot how to do that. So it's hard to explain about the Moldex3D, the character, and our idea about Industry 4.0. So, but one day when I was chatting with my manager, he gave me this puzzle, and suddenly I feel it can explain very clearly about the prospect and our character in the Industry 4.0 era. You can see that is how many parts in the car. Yeah, it seems like it's like a question that we never thought about. It's very common we see a car driving on the road, but have you ever think about like how many components exist in the car? And the answer is really amazing. A single car have about like 10,000 to 30,000 parts. And why I say it's related to our character in the Industry 4.0 era is because you can see so many parts, maybe 25,000, but all simply can use one software, Moldex3D. Then we can run a simulation. So it's an opportunity. It means opportunity. But also, it also means another word, vocabulary is called challenge. Because maybe like a holder, okay, or like a panel, the size is totally different, as you can see in here. And this part, the size is so big different, and the feature is also different. It means that while we run the simulation, while you're doing this one, do the manufacturing, the challenge we'll face is totally different, and the process and the material we select, and also like temperature setting, what we need to consider is totally different. So I use the number in here. I want to explain two things. In the Industry 4.0, just like here, there are so many opportunities, but at the same time, so many challenges. So how to solve it? We'll use one simple topic to explain about today. We will use smart simulation. But how to make a simulation smart? Let me use two successful stories today and share to you. So you can see in here, after the Industry 3rd era, we start to use Moldex3D or another CAE software in our workflow. So just like here, a designer will use Moldex3D, and with a complete mode analysis, machine analysis, then they can output with the machine interface process parameter, here also with Moldex3D, and also the result of Moldex3D, right? Then send to the MES and go to the manufacturing. But if they add one more things, can make the things more effective. That is, we just add the data into the database. And it's a very common method. like everyone, we're trying to build the big data. We always talk about big data in the Industry 4. But in the traditional industry workflow, if we today only build the mold, okay, run the process, go in here and go here. If we want to build with the big data, sometimes there is some disadvantage. Okay, spend time, spend money. So how to use CAE to save time and make it more efficiency? Later, I will use one successful story to talk about this. So it's also explain about the character of what we want to do and how can we help our customer in the Industry 4.0. It's just like here. You can see in this slide, normally, if we look about the workflow, a traditional procedure of the industry, okay, about the manufacturing, it always like it will be two parts. For one product, it will be two parts. First, we need to design it, okay. Then we need to send the 2D or 3D CAD file to the manufacturing side, okay. Then manufacturer will try to build it and finish it injection. So if we simplify about this procedure, it can be two parts. But making a mold or drawing, like design a mold, is not the annoying things. Actually, for me and for some of our customers, the most annoying thing is communication. How could I convince the manufacturing to change design, or how manufacturing to understood their customer need? So some customer ask me, hey Jack, what is the character of Moldex3D? How can you help me? My idea is don't take this one as a simulation software. It's your friend. I would say I will use one vocabulary to explain about Moldex3D. It's bridge. Okay, we bridge an efficient way to lead the critical product with multiple solutions for one product. So they have broad range of solutions to solve the problem, and it helps them to build a communication bridge between them by using the CAE data. And after the CAE data, they can also save as a big data. So they can help them for a long time. Okay, so let me explain today's outline. Today's outline I'll separate into three parts. The first part will be the successful story 1, and this story is about how our customer build the database by Moldex3D. And the second part will be our idea. We just build a system, how we integrate about all our application and become a system and help our customer. So it's called SDM system, which is also means smart design manufacturing system. Okay. Of course, I introduced about SDM system, so I also will share a successful story about that. Okay, so today we have two successful stories, and in the future, and the end, I will summarize what we are going to do in the future. Okay, let's move on. So the first story is about Moldex3D, and we collaborate with the audits, one our old partner. Okay. So audit, what kind of problem they face? Actually, you can see their product. Basically, is VCN precision component. Okay, and size is not big, not so big. Okay, so it's something like lens or VCN holder, sensor, or driver IC. So, but there are so many kind of product, and maybe size is still have some different. So what they need to concern is everything is different. Okay, so what they are going to do by using Moldex3D, they have been used for our product for a long time, but they want to make it better. Not only they don't want to only use Moldex3D, they also want to make it connect to their workflow. So they have two perspectives, and they want to check if Moldex3D can help them. So it will be 2S. What is 2S? First S, shorten the mold cycle time and product development schedule. And this, I believe that everyone agree. They also want that. Okay, want to shorten the mold cycle time, save the money, and product development schedule to win the competition with their, like in the industry, right? And the second S is save the budget on molding. Like here, their target is 160,000 USD dollars, right? So I believe everyone wants to save the money, but also with more product, with more customer. So how can they do that? Here's came out the idea with Moldex3D. They want to establish about the criterion by database. Because while we are doing our work, the workflow, actually a lot of things is regular and it will be repeat. But sometimes design will change. So I don't have reference. How can I move forward? So therefore, we build a reference by themselves, but with something like is trustable. Okay, so like they build the process condition into the database, or like things like so many products, right? So in different products, definitely there are some different runner dimension. So they also put the data of runner dimension into a database. And third thing is very special. It's things like they say troubleshooting. It looked like a little bit weird compared to the process condition and runner dimension, but actually it's very important. Why? Because more and more industry now face one scenario about the manpower gap, right? The manpower gap. So every time somehow some people will resign or some people will retired, and you need to hire more and more people, and freshmen know nothing. How can we make them easier to understand their job and to promote and to have more work ability? Now, how to inherit about this kind of knowledge? The troubleshooting in the database, therefore, is very important. Okay, so how to build it? I will separate into 6 stages. So first stage will be like we need to define what kind of content we need to put in database, of course. Okay, so we can collect the database. Stage 2, we need to build the database by using Moldex3D. Okay, and we need to review on the simulation result. Why? Because we want the database is reliable. If today you have a database, but the accuracy and reliability is only like 30%, how come you can use this kind of database, right? So after review, we improve it in the stage 4. And in stage 5, based on this kind of result, we build a standardized, build a criterion in the database. And the 6th stage, we will send to the department, every department for the practical use. And after their experience and their feedback, maybe we'll go back to stage 1, do some revise, and make the data inside the database more and more. Okay, so I will use a few slides to explain each stage. Okay, so stage 1 is we do define the content in database. Okay, so the traditional injection molding is just like here. We put the plastic, screw, it starts crashing, move forward, and injection into the part, into the mold, and we have a product. So it has so many stages, like product, you can save the 2D, 3D CAD file, the product dimension, the material data, and the mold, you need to record the mold layout, or like a runner or cooling system. The process, of course, is also important. You can record the process temperature and also the temperature is set up in here, or the data you put in CAE is also okay. Then, as I say in the previous stage, we talk about we need to review the simulation, make it reliable, right? So we also need the result comparison. So result comparison here, like the short shot task, we can compare sprue pressure, flatness, warpage, the critical, critical issue we need to consider in the real product. So the result comparison to improve the accuracy. And the final one is how to troubleshooting. Record the method, like how you solve the warpage, how you solve the sync mark, and how you improve the well light, and how you change the air trap location. You can record it, so in the future, when someone inquiry about your precision, he can understand and help you very quick. And it also increase the efficiency at the same time. And the stage 2, we need to build the database by Moldex3D. So actually step 1 is very easy. Just you need to use Moldex3D. But using this one to run the simulation, of course, more and more is good. Like this customer, they already run more than 200 sets. Okay, so this kind of database help a lot for him. Okay, and after run simulation, it's not enough. Okay, because why we need database? It definitely need to help the company. So the database need to be comprehensive, very comprehensive. Okay, so not only design group can use, more trial group, manufacturing group, the QA, the quality assurance group, they should all could use about this kind of things. Or even sales group, they can also use it. Then this is a good database. So you can request more information from the design group. Okay, more trial group, you can request about the process and social test sample, something like that. So if you just collect the data from each group and build a database, then this database can also help you become a very good bridge for the communication. Okay, and step 3 is you need to evaluate and improve the accuracy, as I say. Okay, summarize comparison data between the real and simulation. So not the simulation, as here I say simulation. It's just that we do some prediction, but the CAE is based on theory. So in the every CAE software is now cannot be 100% every time to do the accuracy, right? But we can help you to do the mode trial inside the software. Okay, so you can do the mode trial in the software, and that's why the customer they select Moldex3D to build a database. Because in the reality, if they need to run 200 sets, and for each set they maybe have 12 mode trial, it spend too much money. So they need Moldex3D to do the mode trial inside the computer. Okay, but at the same time, we still need a real product. Even you have a mode trial multiple times, at the final stage, remember to save your real product and CAE data. Make a comparison. So the comparison will be like here. Okay, we have analysis data. We can measure about the fairness. Okay, and reality. Then they can also have data compared to the XYZ and here XYZ. And or you can select the point and use here to collect the data to make a comparison. And also they can compare about the rawness for some component they need to connect. So rawness is very important. So we also could output about the rawness in the studio. In reality here, okay, and about the sprue pressure, okay, the short test, we test about the sprue pressure and compare to reality. So here is the information about the database. Like product information is very clear, and more information like two plan mode or 3 plan mode. Okay, the round dimension, more layout. Then about the process condition. Okay, the melt temperature, mold temperature, the screw diameter, and also the distance like screw forward. Okay, and final is the result comparison. Using this one to review the result and make it more accurate. Okay, so stage 3 is the things I always talk about. Okay, is review, because we want the database is reliable. We don't use if this is not reliable, it also hurt about the money, right? Because we use a bad design, and at the end we still need to go back to revise the design. So we want the database is reliable. Okay, so in this case, okay, they find out. They classify the raw product. In the beginning, I show you the component, 30,000, right? So many different size. So classify product according to the usage, dimension, and material. Okay, to make sure that similar material and similar usage and similar dimension, then you use the similar database. Then it could be reliable. It's impossible like you use a 200 millimeters the panel, and compared to the precision component, like only 1 millimeter. It's impossible. The criterion of these two products is totally different, right? And then you need to review the simulation accuracy. At the beginning, they didn't do any revise. They found out the accuracy is 71%. It's not their perspective. 31% is not enough for them. Okay, so they start to review. They found out 2 potential results. It might cause the deviation according to a review. Okay, so 2 things is maybe it's because about the material data. Okay, maybe because about the process condition. So they start to do some tests, more trial in CAE in the Moldex3D. So it's like here, stage 4, improve it. Okay, so they found out one thing. Okay, the problem in here actually is about the cooling system, the temperature consideration. Okay, the temperature effect, they consider what they input, something is wrong. So do some more trial test. After they revise, okay, the melt temperature, they change. Okay, they found out that the accuracy have 50% improvement. Okay, so from 71% to 86%. So it's become more accurate and achieve their perspective. Okay, so they start to want to use this database they want to input this kind of data into their database. So it will become stage 5, building the database of criterion. Then the round dimension. Next time, when you start to do the design and you don't know the round dimension or mode layout, go to round dimension database. Then you have a criterion. You have a reference. What should I start and what I can build. Okay, and also a process. At the beginning, you don't have the default process. You don't want to follow the Moldex. You want to follow yours. Yeah, it's good. Okay, so you can use the round dimension and process condition and run the simulation, and to figure out if this time your design is okay or not. Right? So you reduce the more trial time, not only in the reality, also in the CAE. And final, don't forget to record about the troubleshooting every time, because the next time when everyone want to pass your job, or if you are taking day off, yeah, the work will be okay. Don't worry about it. So make sure you save about the troubleshooting. Okay, so build a database like here. So what can they do? You can see they can affect so many departments. Okay, so like more design, they can establish about internal specification to optimize the design. Once they receive the request, what kind of product they need to build, then they have a basic idea because of the database. Then move forward to CAE engineer. They can improve the accuracy because I review back to a process and also the round dimension and also how to troubleshooting. It helps the CAE engineer to improve the accuracy on the simulation. And also I can go back feedback to the database. So database will become more and more useful. And the machine operator, yeah, they can design the process based on the standard criterion. So sometimes maybe only machine operator, they don't want to go through a designer or CAE engineer. They only want to a simple design, and then they want to design process. It's okay. The machine operator can do that. Okay. Then quality assurance, they know how to troubleshooting in here. And also sales can also receive the benefit in here. Yeah, because once they want to evaluate the cost and what kind of thing they want to, if they need to buy some components, they can use the ones to evaluate about the cost, not spend too much, and also consider how much I should sell to my customer, right? So this is the efficiency, and this is the effect on the database. Okay, so take 100 set for a mode, like for this customer, for example. Okay, they have 100 sets in the past year. Okay, how much money they save? For the mode trial, there basically are two parts: mode trial and material. And we can directly see the conclusion. They save the money is around more than 600 and 160 USD. 160,000 US dollars. And do you remember their prospect? They want the cost down is larger than 160 USD dollar, right? They did it in here. Okay, just because they do the database, it helps a lot. Make a CAE become the real helpful work. Actually, it's not like that. It's like make the CAE become more helpful into their workflow. Already helped them a lot for a long time, but become more helpful in the workflow. Okay, so this is the first success story. Okay, so after the first success story is the database built by our customer by using Moldex3D, right? But and then we'll forward, go back to Moldex3D. How come I can say we are smart simulation? Are we ready? What kind of application can we use for the smart simulation? Okay, so I will talk about in here. Moldex3D in the industry 4.0. Okay, so in the previous page, in the previous success story, we talk about database. And when we want to build a database, we need it is very comprehensive, right? So make it comprehensive. It means we need to consider each stage in the real process. Like here, from the material I put in, the material modeling, machine, no matter it's hydraulic or electric, okay, the machine response, filling, packing, cooling, work page, and structural analysis, mold structure and simulation. Then do the optimization, okay. Then after that, you need to output the realistic machine interface, and then go to the manufacturer side and finish the modeling. Okay, so always like this kind of circle. Okay, so we need to build a good mesh for the modeling, go through here. So in each stage, what Moldex3D, what kind of application did Moldex3D provide? Okay, so it will be three main parts. First is the smart material. Material is a very important section in simulation, okay? Because if you use different material, how it react will be totally different. So don't forget, every time make sure material is correct. Okay, so smart material. Then the machine, what we select, the process also, we want this smart. So smart machine and smart process. And the third is the smart modeling and smart simulation. Okay, so we also need this kind of information. Okay, so what kind of tool we have? First is called Sync. Sync is a tool that we integrate with the leading CAD. So in a lot of company, okay, they mostly is CAD engineer, not CAE engineer. So when you request them to do a CAE, they will say, but how? It's hard, right? So therefore, we develop about a Sync. The Sync is like the user can use the Moldex3D. They can build a model directly in the NS, in the Creo, in the SolidWorks, the leading CAD. Okay, and then they can run the simulation directly in the Sync, in the NS, in the Creo, in the SolidWorks. Okay, so even a CAD engineer can learn very fast from part design, more innovation. All of these parts is all in the CAD file, in the CAD software. So even a CAD engineer, okay, it's easy to learn about CAE. It can help to solve the problem of the manpower gap. And then for about the smart material, for the material, we have a material lab in our headquarters. Okay, we can measure about, because like as we say, the material property is very important to the CAE. How important? It's just like here, our measure material. The tendency is like here, but it's quite different from the actual. But after we measure it, you can see the wrap in here. The wrap phenomena in here, we can simulate it. And in each stage, like viscosity, okay, it will affect maybe clamping force and air trap and weld line, because viscosity will affect the flow pattern. And the PVT, of course, it will affect about the shrinkage, the work page and roundness. Heat capacity will affect about the also about the work page and some like specific heat, and also heat transfer coefficient. And the last one is the mechanical property. Even though a structural analysis is not our strength, we also have like FA interface. We can help user to output the CA data into another structural software to do the structural analysis, right? So we also have a mechanical property to measure in our lab. So apart from the measurement, we do the good measurement and also have a strong team in the lab. We also have some special pattern. And the most special one is also very important in the real is fiber. Okay, so we can say that Moldex3D have a very strong fiber tool. Okay, so like here in the 2017, we are invited to the USDOE project. Okay, and they want to do some simulation comparison at that time, and we win another software at that time. You can see almost 90% achievement, like higher than their prospect. So we have a strong pattern in the fiber simulation. And also in this year, we have a new pattern. Actually, it's last year. In 2019, we have a new pattern about the fiber. It's called fiber coupling. Okay, fiber coupling is like that. This is only can be used in the Moldex3D. You can see decoupling. If today there is a compression molding, we put the charge in here and start to compress. In the traditional simulation, it will start to expand like this one. But in the full coupling, in reality, it should look like here. And if I open the coupling, fiber coupling, the simulation will be more accurate, become like here. Okay, why? Because like in the previous, everyone, when we do the simulation, viscosity will create the stress, right? And stress will induce the flow. Some will affect the flow behavior. Flow will change the orientation. But in the previous, it's like going this way. This way is not passed. But with the coupling, we figure out how to get this one become connect. So it will, from the viscosity, will also affect orientation. And orientation will also affect the viscosity with this kind of a circle. Okay, then we can have a more accurate simulation. And this one is only work in Moldex3D. And the machine will, of course, we want it very smart, right? Even though, no matter it's hydraulic or electric. So we have a service called machine characterization, okay? Because like in the machine, a real curve, maybe sometimes it's not close to reality. So we also need to do some curve fitting to make sure it's more accurate. So just like here, okay, to see why we need the machine character, okay? Because like you can see the screw head in here, and here is the nozzle. Here is the melt inlet, okay? The flow rate will be different. It's because the pressure, the material is compressible, okay? So the flow rate will be different. The plastic will absorb about the pressure and cannot be released. Or of course, and also like a response curve in the fully electric and hydraulic, the response curve, the timing, you can see from 0 to 62 cc second. The hydraulic need 2 seconds, but the full electric maybe only 0.5. Then they achieve. But in the CAE, okay, it's more perfect. It's more ideal. Okay, so we also need to do the characterization to fit about this work problem. But if you don't do this kind of service, it's fine because we have machine mode. Okay, so we have some basic solution for this kind of different machine react. And I think it's around like R16, R15 or R14, we already have the real machine, the realistic Moldex machine interface, just like here. Okay, you can see that this is the real machine panel, and here is the Moldex3D machine interface. So how come we have this one? It's easy, just like in the future after you running the simulation, but for the real manufacturing, they cannot read the table. For them, it's hard. They only read the panel. Then you can print about this kind of information, okay, and then give to the manufacturer. Then they can input the data, okay. So the reality and CAE can also connect by our technology. And also, at the end, we still need to run a simulation, right? So while running the simulation, we need multiple modules. So therefore, like you can see here is compression, okay, channel injection molding, or the temperature inside the mold, like here inside the mold, or the temperature across the cross-section area, how to observe. It can all support in our software. And now it's more easier because we have studio release start from the last year. From the 2019, we still have a studio. It's an interface like integrate about from the modeling, machine material, process, analysis, results, and reports. You can do everything in this plan, okay? And then finish your simulation. So make it work more easier, and also at the same time, help you to create more business. Okay, but even we talk about the smart material, smart modeling, smart simulation, smart machine, smart process, all of this, they still need a key. The smart people. Because we select material, we still need to rely on people to do that. AI cannot do that currently. Even machine can help us to throw the material. We still need to decide what kind of material into input, right? And we still need to modeling. Now AI cannot do that, so we still need smart people. And as I said before, we face a serious problem is the manpower gap. So we also try to solve about this kind of problem for our customer. Therefore, in the last year, actually it's 2018, we published about this book, the Moldex3D molding simulation book series. Okay, it's about our theory and if you would like to learn about it, there's a theory inside and also the practice inside. Okay, and also we have an MPE system. If you would like to use it, you can ask yourselves. Okay, in here you have a lot of course based on the injection molding machine. Okay, so I talk a lot, but what's different? Maybe a little bit confused. Actually, it's like that. In the Industry 3 era, the CE simulation is only focused on here area. In this area, we have a runner, mold base, cooling system. Then we finish the simulation. That's the CE before, and now we consider from software material, from the mold inside. The mold inside, the material, and the machine. We all consider. But what about the future? In the future, it's like total process. All the factory simulation, the modeling, and consider about the big data, as we say before, like our customer did. We integrate this together, so in the future, CAE can help the factory to work effectively. So we still need a success story to prove that what we did, right? So here is a successful story. So it's our old friend, okay? It's called C-Mold Technology. They faced one problem. The pain point for them is the shortage of the trained talent. There's only one CAE engineer in their group, but they have a lot of work. So how to do that? Okay, they have one CAE engineer, but they have 10 CAD engineer. But CAD engineer, as I say, it's hard for them to learn the CAE, so SDN system can help them. This is kind of project. Our guys will come to their company to train them about the CAE knowledge and also help them to use the familiar system, or like here is NX. They can use the CAD system to learn CAE. And then the engineer, like here, we can say, we try to performance extend from 1 engineer to 11. So we want to help that 10 CAD engineer can also work in the CAE field by a very quick time. By a very short time, they can work on it. So let me use the video to explain about this one. Okay, so you can see this is, I believe that a lot of guys is very familiar with this kind of interface. Is NX. So you can see you can build a model in here. After you build the CAD, you only need to assign the attribute. Okay. Assign the attribute. So I will quick jump in here. Okay. Assign the attribute. And then you can set up the process in here. Like here is a machine mode. Okay. What kind of material, what kind of machine you are going to use. And of course, you need to select the material and set up the process. Okay. And set up the process in here. It's all in the NX interface. So even you are a CAD engineer, you can learn very fast. We hope that this kind of system, because I use the series to introduce our tool, right? It's all integrated into this system. So therefore, even you are a CAD engineer or you face a problem like most of your engineer, there is only one CAE engineer. How come you can integrate into your workflow? Don't worry. If you consider all our product, it can help you to build it. And if you are interested, you can ask our sales for help about this one. Because this is a special project. we need to collaborate and then forward. So like here, you can see the NX in here. They can check the result directly in NX. Like here, NX check the result. And also, after checking the result, they can make the product, make the report in here. Okay, just like here, make a report. And also they can output about the machine interface parameter in here, right? So when you provide this report to manufacturing, they will not get confused, like what can they do, right? So you have a machine interface parameter. Okay. So what can, and we are going to move on forward to the final stage about Moldex3D in the future. So we talk about a lot in here, in this kind of industry. Here, also the same as a topic. You can read about a topic. Actually, this is our perspective. The Moldex3D in the Industry 4.0 is we are trying to modeling and the data integration. Because CAE can provide visualize results and also the data. So it's help customer to build the data integration and spend less money on it. And also we can help the modeling more quickly. Okay. And the 4.0 plus in the future, what we are going to do? Our perspective is we want to be the brand behind the industry. We want to integrate not only big data, but also the AI machine learning into the simulation. So become more advanced. In the future, if you like to check the Moldex3D, you have big data. At the same time, you also can use, we can give you some advice based on the AI machine learning results. And this is our perspective. We hope we can be the brand behind the industry. We can hope we can be a brand behind your industry and before the smart design and manufacturing. Okay, thank you guys.